Well, it's that time of the week again. It's time for Programming by Stealth, and this is Tidbit 13, recorded July 19th, 2025. I'm your host, Allison Sheridan, and of course, I'm joined by your co-host, Bart Buchatz. Now, I kidded around with Bart. I said, this is an American-sized tidbit. It's a tidbit, but it's a fat tidbit. It's a good one.
It depends on how deep you decide to go, I guess. And I also gave real thought to, do I make this 12A or do I just accept the fact that the number 13 exists and I shouldn't be so childish?
Oh, it's going to go great. Now you've done it. Jinx.
Actually, the last time I had a really big presentation in work, it was Friday the 13th and it went really well. So I'm going to lean into it.
There you go.
Right. So, one of the things I have always evangelized as part of the reason this whole PBS thing exists is that I think the ability to write code is empowering. I think it's a skill to have because it lets you master the computer to do what you want. And you have an idea and you can make it real. Or you want to test something and you can do it. And sometimes that's like a huge piece of work like XKPassWD. And sometimes it's a throwaway script that you run once, it does a thing, and you never think about it again. And everything in between. And I always sort of have that in the back of my mind. And then the root cause of this little tidbit is another thing I love about having coding skills, is that it lets you experiment with things. Because if you have code, you can make it go again. Right? There's that joke about an engineer sees a car crash. He goes, again. What happens if we change this variable, right? Well, in a computer, you can. And so I want to sort of show rather than tell. And in the process, I've sort of used this as a second teaser. I was mentally thinking about, like, the way when there's a big movie, you get a teaser trailer, and we did that a few months ago. Mm-hmm. And then halfway between the teaser and the movie coming out, there's like a bigger trailer. This is the bigger trailer for PowerShell. Because that is still next on our agenda.
This is so mean.
But I wanted to do this.
Yeah, I definitely love this as the main, sort of the backbone of what Programming by Stealth has become, to me, is my ability now to experiment and write things and automate. And maybe I'm not using everything that you've taught us, because you've taught us an awful lot, and some of it's quite a bit rusty, but it's more like what you've set out to do, which is stealthily just make us want to code. Make us want to try to do things and automate. Like, I now know there's going to be a way to automate that. I may not have the skills, but now I know how to go find them. I know how to ask the right questions, and I'm motivated to try to solve these little and big problems. And that's exciting. That, like you say, that's empowering. It's my favorite thing about Programming by Stealth.
Yeah. So all of this came about because just as I was starting some annual leave, I was listening to some podcast, and I don't even remember what it was. It was a podcast. I listened to hundreds. And there was a discussion about AI. And in passing, they mentioned something I always knew I didn't fully understand. And it always made me cranky that there's a thing I don't fully understand. I don't like that. So anyway, if you're the kind of person who's not like me, because I listen to podcasts and I never look at the title, and I'm perpetually surprised by the subject of every show. So if you haven't looked up at the title, it says PowerShell Tames Monty. What? That's a bit of an odd title. So it's the Monty Hall problem. So the discussion on AI was saying that one of the things we have to be aware of to avoid the dangers of AI is that humans are predictably illogical, and that can be used to fool us, to manipulate us. And the example given was the Monty Hall problem, which we'll talk through in a sec. But basically, it's a thing that people's first instinct is not universally, but pretty darn close to universally wrong.
Including you.
Assumptions, including me. And I spent ages trying to fully understand it, and I got halfway to an understanding. And even at that point, I was still missing a really big thing. So, there's a lot here. And so I wanted to write a script so that I could poke at it.
So you could prove what you thought you knew and understood?
Yeah. And the act of writing the code caused the penny to drop
Oh. Oh, interesting.
because I was looking at it from the point of view of the contestant because it's always set up as you're the contestant.
We haven't explained what it is yet, so don't jump into it too close.
Very, very hand waving here. You're trying to win a car. And I always looked at it from the point of view of trying to win the car. But the reason the answer is because there's a second point of view.
Hmm.
You have to look at it from the host's point of view. And when you're writing the code, you have to code both players in the game. And as I was writing the code for what the host would do, I was like, oh, that's important. And then it finally clicked.
Writing the code helped you figure out why the answer is what the answer is.
Yeah.
Huh.
Yeah, because describing it in English never forced me to look at every point of view.
Okay.
Writing the code forced me to. Because how do you write the code if you don't look at it from that point of view? Right. Okay. So I also learned a lot about the Monty Hall problem while writing these show notes because I needed to set this up. I assumed this was a real TV show in America, but it's only sort of a real TV show. It's based on.
What is a real
I'm
TV
going to
show?
describe it. So Monty Hall is a real person, or he was. I presume he's passed since, unless he's very old. Very old. So he was a TV game show host on a show that I found out is still running called Let's Make a Deal. It started like in the 70s and it's still going, not with Monty Hall as the host. And the basic idea is that you're shown a thing and you can trade the thing you're shown for something you don't know. And that's the fun, right? Do I make a deal with Monty for the mystery thing and do I end up with something silly, or do I accept this something okay? Right? There's a bit more to it than that, but that's kind of the basic idea. There's an unknown thing. It might be better than what I have. What do I do? Right?
So before you get too far, he made it to 96 years old, but he passed in 2017. I'm a little confused by you saying you thought this was a real thing. He was, in 1963, he was best known as the game show host of Let's Make a Deal.
Yes, he was, absolutely. But this game was never on that TV show. It was inspired by the TV show, but the puzzle...
Oh, I see what you're saying. So the puzzle you're going to talk about that we keep dancing around here was not on when he was on?
It was never on television at all. It's only ever existed as a maths puzzle, named after the most famous TV show host who was Monty Hall, and everyone just assumes it's from the television show. It's from a mathematics magazine.
Oh, I'm gonna have to research that myself because I remember this game. So
The show existed.
Talk through. No. What the game was, Let's Make a Deal, was I remember there being doors with goats behind them. 100%. I remember always wondering, why did the woman want the washing machine and she was sad when she got the goat? Because to me, when I was a little kid, the goat sounded awesome. Wouldn't it be cool to have a goat? Why would you want a washing machine?
Maybe it was that it was never a car. Maybe the rules were a little different. The problem as we know it was sent in as a puzzle to the readers of The American Statistician, which was a magazine. And I guess writing a letter to a magazine was the social media of the 1970s.
Okay.
And so this letter said, suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car. Behind the others, goats. You pick a door. Say number 1. And the host, who knows what's behind the doors, opens another door. Say number 3, which has a goat. He then says to you, do you want to pick door number 2? Is it to your advantage to switch your choice?
Right.
So that was a probability problem. Dear readers of The American Statistician, what do you think? And that was in 1975. And to this day, it baffles people. It's wonderful.
And actually, I'm still a little bit baffled. I read the show notes 3 times, I think, and I almost could explain it, but not quite. So I'm hoping this 4th time through, when you explain it to me how the answer works, I'm going to get it.
Right. So you have 3 doors, 1 shiny car, 2 silly goats. So you pick a door, the door opens, the host opens one of the wrong doors, and then you get to decide original choice or change your mind. What do you want to do? And so everyone assumes that you have a 1 in 3 chance of the car being behind any door. So what difference does it make? There's a 1 in 3 chance of door number 1, a 1 in 3 chance of door number 2. Why would changing a door change anything? And
Right.
that's most people's first impression, which is definitely totally wrong. What's actually true is that if you switch, you double your chances of winning 2 out of 3 times, more than half, which is head exploding.
Okay,
That
so let's say
seems wrong.
let's say this again. So there's 3 doors. I pick door number 1. Monty opens door number 2. I get a significantly better chance of winning if I switch to door number 2. Goes from 1 out of 3 to 2 out of 3.
Yeah.
Okay?
And I keep hearing mathematicians tell me, and they use all sorts of big words, and I go, oh, okay. And before I really dove into this, there was one thing they said that stuck. So that was the little kernel of the truth that had drilled in. So we all know that it's another way we're predictably wrong is if I give you a dice and you throw it 5 times and you get 5 sixes, humans think that the chance of another 6 is tiny. You couldn't possibly throw another 6.
But we all know
But
that's
it's
not
still
true.
1 in 6.
The people listening to this
Yeah.
show, that's not know that one.
Yeah,
It still
Right.
feels like it, but it's not.
exactly. Because the reason is because the dice doesn't know anything about the previous times it was thrown. They're disconnected events. So each time it's 1 in 6.
Right.
But Monty knows where the car is. He's not randomly choosing a door. His choice is limited by your choice. So they're
Ah.
connected events. So
Okay.
that changes all the maths. And that much I understood. So because Monty has knowledge, it's not like rolling dice. Therefore, something.
Okay.
And then I heard math, yada, 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 yada.
Math.
Yeah, it's like what the Peanuts cartoons, right?
Okay.
Yeah, that's it. That's a much better impression. So I figured, right, I'm just going to write the code. I am going to write some code that picks a random number, does whatever Monty does, and then does both things and records the results.
Does both
And then run it
things.
1,000 times. So Monty says, do you want to stick or do you want to switch? So I was like, fine, I'll just try, see what happens if I do both.
So stick 1,000 times and switch 1,000 times.
We'll run
Or
the same game and just record the 2 outcomes. In the real world, you don't get to have a do-over, right? But in my simulation, I can just record the results each time. I can do it in
That
parallel.
isn't what I just said? Is it different than
It's
what I
not
said?
what I heard. That doesn't mean it wasn't what you said. It's not what I heard. Doesn't mean it wasn't what you said.
Okay, there must be some nuance in there probably that I'm not getting, but okay.
Yeah. So I figured that'll just show me, right? If I do it, I can watch it and then I can run it 1,000 times, 10,000 times, and I can see what happens. And so actually, I should back up 1 second. So the first time I choose a door, it's definitely a 1 in 3 chance of being right. That
Good.
much undeniable. Once Monty opens a door, I get to choose again, but now there's only 2 doors. One of them has a goat and one of them has a car. So I figure if I randomly pick a door from those 2, my odds have gone to 50-50. 1 goat, 1 car, 50-50. 50-50 is better than 1 in 3.
Is that still true? Or are we
That
wrong
is
about
absolutely
that?
still true.
Okay, good.
No,
good.
we're not wrong about that.
Okay, so
So
1 in 3 at the beginning. Once he picks a door, now it's 1 in 2.
if I just randomly choose again, so I choose randomly 1 in 3, he does his thing. I ignore my first choice, then just choose randomly from the remaining 2 doors. I'm now a 1 in 2 chance, which is better.
Okay.
So I already got, okay, well, that's how I can improve things. Great. that gets me to 1 and 50-50.
But you have
the
to randomly
mathematician-
choose, not randomly.
Random.
You're not saying random. You're not saying stick with the first one gets you a 50-50.
No, I'm saying just throw another flip a coin.
But you have to flip a coin to get from
You have to flip a
1
coin,
and
and then you're
3
back
to
to 50-50.
50-50. Okay,
Yeah.
but you'll explain why.
Well, so there are now 2 possibilities. One of them definitely has a car. One of them definitely has a goat. So if I choose randomly, I'm now at a 1 and 2 choice, right? Play the game 1,000 times, you get 500 cars and
But-
500 goats.
But there's equal probability of it being behind the 2 doors. So if I
Right.
stick, if I always say heads, every time you flip a coin, I'm right 50% of the time.
That is true for coins, and that is what I would intuitively think for the Monty Hall problem.
But it's not.
But that would be wrong.
Okay.
However, randomly choosing would be 50-50. Why that's wrong is what I didn't understand.
Okay.
That was the bit that my
I'm
brain
right at
was
the
going,
crux.
What?
Okay.
And the other thing that made my head explode was by what laws of reality can you make your chances better than 50-50? How can you be more likely to get a car than not?
So we're learning 2 things here, neither of which I accept yet, but you'll prove it.
All right.
Is that randomly switching increases my odds to 50-50. Sticking does not. And switching makes it even better.
Yeah.
Ugh. Okay.
I know.
Prove it.
Right. It's like, I don't understand this.
Okay.
That's why I needed a script, right? I needed to code this up. This was not working, and the mathematicians were not helping. No,
Maths.
Yeah. So I started writing the code. And this is where I sort of realized that code is more expressive than English, because I wrote the code to make my choice. And then I wrote the code for Monty's choice. And I was like, oh, wait, got to be careful here, because I can pick any door. Random number between 1 and 3, job done. Very, very simple piece of code. But Monty is not allowed to show me a car, because that would obviously mean I knew exactly what to do, right? Monty's just shown me the car.
Mm-hmm.
Monty's not allowed to show me my door, because that's my door already. So Monty is actually quite constrained. And it turns out that he's very, very, very constrained. Let us imagine so the mathematicians insist that the right answer is to always switch. So fine. 1 and 3 times, I'm going to guess right. 2 and 3 times, I'm going to guess wrong. What happens from Monty's point of view for both of those 2 realities?
Okay.
I guess right. Monty has 2 doors with 2 goats.
Okay. So you've picked the door
Right.
that has the car, but you don't know it yet. And
I don't
Monty's
know.
got 2
Yeah.
goats to choose from.
So it doesn't matter a darn. Monty just randomly tosses a coin, whatever he does, picks a door and shows it to me. I always switch, so I throw away a perfectly good car and get myself a goat.
Okay.
Oh, well.
So if you picked right
Now
the
what
first time
happens-
and switched, because we're going to believe that always switching works, in that one
Yeah.
doesn't always work, gives you a higher chance. You pick the goat.
Right door, you're guaranteed a goat. You start,
Okay.
you get it right the first time, you're guaranteed a goat.
Okay.
What happens if I pick wrong the first time, which is more likely that I'm wrong, right? That happens twice as often as
Oh.
being right.
The chances that you guess wrong are higher. So
Twice as high.
switching doubles your chances.
Right, but now look at it from Monty's point of view, right? So I picked the wrong door. Monty has 2 doors left. He knows where the car is. One of those 2 doors has a car. He's not allowed to show me the car. He has 0 choice.
Okay.
There's only 1 door he could open,
Okay.
which means he's told me where the car is. I switch and I get the car every time I'm wrong. So I play 100 games. I get 66 cars.
I think the penny might have dropped.
And it's purely, I was writing the code to pick Monty's door. And I realized that 2/3 of the time, it was an array of length 1.
I don't know what that means.
Why am I always randomly picking between 1 and 1? And
Wait,
I was like,
wait. I don't
because...
accept this. It's an array of length 1. What? You leaped.
Okay, so I was writing the code for Monty to choose his door. And so I was looping over my list of possible doors and I was going, can Monty choose door 1? Have I picked door 1? Yes, I have. Then Monty can't. And I was basically doing the rules. What doors can Monty choose between? I'm putting Monty's doors into an array, and then I was going to randomly pick from the array of Monty's doors.
Okay.
And when I ran the code, the array of Monty's doors was sometimes too long. 1/3 of the time, when I had picked the right door, Monty gets 2 choices, so the array was length 2.
Okay.
But the array was length 1 twice as often as it was an array of length 2.
I got you. Yeah.
Oh!
He has no choice.
Monty doesn't have a choice.
Interesting.
And then the penny dropped.
Interesting.
And I hadn't even run the code.
Just
it was
writing the code.
Writing the code. So then I'm like, okay. So if this penny that I think has finally dropped has really dropped, then if I finish writing this code and I run 3 simulations, I should get 3 answers, and I'm going to predict those answers, write the code, and then see if I get what I think. And if I do, then I actually understand this problem. So the first thing was the easy one. If I always stick with my first choice, I will have a 1 in 3 chance. So that's the first thing I wanted to test. If I always stick, 1 in 3. If I randomly choose between the 2 doors that remain, I should get 50-50.
Yeah, I'm not sure I know why that is yet, but I know the third one. Why is it 50-50?
Okay, so 50-50 is in a way the naive case, right? So it's like the dice. I'm pretending there's no connection between my first guess and my second guess. There are now 2 doors, one of which has a car, one of which has a goat, so the laws of probability says that it's 50-50. If I just choose fresh, it's like starting over with 2 doors.
Intellectually, I follow that one, but I still feel like sticking with the one I had is the same as choosing 50-50. That it's the same as randomly choosing, because I'm just always, but I'm, if
that was
you flip a
randomly
coin,
chosen from 1 and 3.
But that doesn't exist anymore. We now have a 50-50 chance of 1 or 2 being correct. So if I always choose 1, I'll be right 50% of the time.
Well, no, because remember that when you made that first choice, there were 3 doors. So what happens in the cases where you chose a door that doesn't exist anymore? You then have to throw a dice or something again.
No, he never picks the door that I picked.
Okay, but I'm trying to explain. There were 3 choices. You randomly picked one of those 3.
Yes.
One of those 3 that you randomly chose between has evaporated. If you always stick, you have now brought information from the first game into the second. If you just choose again as if the first game had never happened, you're starting over, and so it's 2 doors.
Yes.
So it should be 50-50.
As of the I agree, it's 50-50. I'm with you up to being 50-50, but it seems to me that if I always pick door number 1 of 2, that's the same as randomly choosing.
Oh, you mean always pick 1 of 2, not always stay with the door you chose in the first round?
Well, yeah, I guess well, yeah, isn't that the same thing?
No,
yeah, that's a part of it.
Different number of doors.
No, but
if you could choose always to pick the door on the right, right?
Yes.
That would work. That would get you 50-50. Or always pick the door on the left. That would get you 50-50. But sometimes the door on the right is a different door. There were 3 of them. Now there's 2. which one vanished, it could be any of them. So the door on the right could be door number 2 or door number 3. The door on the left could be door number 1 or door number 2.
To me, there's always going to be 2 doors.
Right, but they're not the same 2. They're going to be numbered 1, 3, 2, 3, 2,
whatever. Sure. But I'm calling it door 1. The door 1 is the first door I chose. It's going to be the door I chose. Let's call it A. The door I chose, door A, and then the door that gets left over is door B. That's still there after Monty opens a door. Now we've got A and B. So these are like the brand new doors now. But I was on A before. Staying on A has a 50% chance of being right.
Except for the fact that the car wasn't re-hidden. If the car also changed, then you would be correct. But the car hasn't moved.
Oh.
So to actually start fresh, you need to choose again.
Interesting. Okay. All right. Let's keep going.
So if I understood it right, randomly picking to stick or to switch should give me 50-50. And if I and the mathematicians are correct, always changing door should give me 60-something% success, 66%, 2 out of 3.
Okay.
So that's what I want to see when I run the code. Right. So this is where we get some PowerShell. So you will find the zip file that I will create after we finish recording because I forgot to. But it will be there when you hear this. You will find a PowerShell script because, hey, this is half a teaser for PowerShell as much as it is anything else. And that will play the game a few thousand times and show us what happens. I did a quick and dirty version and then I tidied it up to be a really nice version. So the first thing I want to say is this script is not short because it's meant as an example of a good PowerShell script, not a quick and dirty PowerShell script. So I could have written this in a run once and never look at it again sort of a way in like a quarter as many lines, probably less. But if you want to write code that has a life, you should follow best practices and put things into functions and document things and add comments, those kind of things. And so this code is written as if it was a script I would like to have a life. So it's an example of a best practices PowerShell, not a quick and dirty PowerShell. The second thing is, this is a teaser. So you shouldn't open this file and expect to understand everything based on the teaser we did 7 weeks ago.
7 months ago.
7 months ago. Yeah, there we go. 4 times as long ago. Yeah.
And you know how bad I am at remembering what you told me 2 weeks ago or a month ago. So,
yeah. Now, a lot of the PowerShell will read a bit like pseudocode, so it won't be complete gibberish, but you're not going to get every detail. The nuance is not going to be there, right? But the big picture gist of it, you should be fine, especially because it's well commented. But I will give you a bird's eye view of the code so that you can sort of look at it and see the pieces so that if you'd like to scroll about, you have a chance. So the very top of the file for quite a decent chunk is the help comments. And this is what PowerShell calls the JS doc we would have done in JavaScript. So that sort of, they're comments, but there's a little bit of a syntax to them which turns them into documentation. So in this case, it's period uppercase parameter to describe a parameter, period syntax to show like the little summary of, actually, sorry, not period syntax, period description and period synopsis. I'm going by memory.
Oh, that's cool. So writing comments turns into the documentation so you can be told like what flags you can use and things like that automatically.
Yes.
That's kind of neat.
Yes. Very neat. It's very powerful to make use of that feature. So they're called help comments and they're very helpful. So I did that because this is, teaser here. So that's the top of the code. The next thing is the begin block, which is where you have initialization code. So if you're writing PowerShell for real, the begin block is where you do your setup tasks to create whatever it is you're going to need to do your work. And so what I have is 2 caches, 2 variables that are going to cache random numbers, and I'll explain why I'm caching them. It's because I'm a good person, but we'll explain that in a sec.
You are a good person, Bart. I don't think we needed this to know that, but okay.
Considerate is actually the word I was looking for.
Okay.
I respect other people's APIs,
Hmm.
shall we say. And then there's some helper functions to actually do the random stuff. So if I'm going to cache the numbers, I got to go fetch them, put them in the cache. And if they're in the cache, how do I get them out of the cache when I want one? Right. So a couple of little functions. And each function is documented as well with help comments. So that's where you're going to see a little bit of repetition, dot parameter and stuff, because it's now describing those functions. And that helps VS Code to understand what code completion to offer me. Because VS Code can read those help comments just like everything else can.
Oh, okay.
Then there's the process block, and the process block is where we do the work. So the first thing we do in there is we validate our parameters to make sure that there's nothing problematic in the parameters we received. And then we run the simulation. So we define a few variables to act as little counters so that we can keep track of how many times we won the car and how many times we didn't. And then there's a loop, a for each loop as it happens. And in that loop, we do the work, which is pick a random door, let Monty open a door, and then for every time we do that, calculate the result of each of our 3 strategies. So for this game, if I had chosen to always stick, did I win or lose? If I had chosen to make a random choice, see if I win or lose. And if I had chosen to always stick, did I win or lose? So I'm getting a 3 for 1, right? I've used my random numbers once, but I'm getting 3 answers.
Oh, I see what you're doing. Now that's making sense. Okay.
Yeah. And then the last step of the code is output the results, right? We've done our loop, so we now have our answers, so show the answer. And that's the bird's eye view of the code. So random numbers are important here. We're dealing with probability, and in theory, a random number is truly random. Computers are not great at being truly random. They're deterministic. So they tend to have pseudo-random number generators. So if you really want really good random numbers, you ask random.org, who have lava lamps and all sorts of things to make real randomness.
I think this is, I'm glad this came up because I read on random.org, so I was trying to see why were you saying these were good ones, because I could have sworn you told me that computers can't make random numbers. They're pseudo-random numbers. And I read in there that they actually use atmospheric data. And is this the place that does have the lava lamps in the lobby or something like that they say they use? Or was that a urban legend?
So that's Cloudflare.
Cloudflare, okay. But this came up in one of the talks at MacStock, and I can't remember what the context was, but I remember thinking, no, that's not really going to have random numbers because I know computers can't make random numbers. But if they were using random.org with their atmospheric data, then that could be. Cool.
Yeah, so you can pull randomness from somewhere else, but it has to be external to the computer.
Okay.
The randomness has to come from somewhere.
Okay.
And so I mentally knew
because clearly
that
we
years
could not
ago,
trust something as important as this script to pseudo-random numbers, right?
Well, the thing is, pseudo-random numbers tend to have patterns. It's really fun to give a sequence of pseudo-random numbers like a color on the spectrum and just graph it in a grid.
And
what you'll see is bands of color because the random numbers repeat.
Huh.
And if we're playing a game with opening doors and stuff, that pattern could end up really polluting my results.
It would be interesting
to
see what does happen if it gets the wrong answer.
Yeah, so I was like, no, I want good random numbers. I don't want to do all this work to finally understand this and then not understand it because I chose bad random numbers.
Okay.
So I knew that years ago, random.org had an API and it was free. And they always had like, please don't abuse this or we're not going to be able to pay for the servers. So I was like, oh, I hope that still exists. So I went and looked and yes, it does. They still have a free API. They still ask you to not give it too much work. Don't write a script that calls it 5 million times. They don't say exactly what the rules are, but they do say they will blocklist you. So I thought, well, why don't I just ask it for loads of random numbers at once? Because it quite likes that. It can give you up to 10,000 random numbers at a time. Yeah, exactly. So I figure I'll ask for a big chunk and then I'll cache them. And so at the start of my script, I get my random numbers and then I can use them in the loop later. Instead of querying their API every time, which would put a lot of strain on their system, I said, tell you what, give me a load of random numbers and I'll keep them and then I'll use them. So that's why I did it that way.
So every time this runs, it's using that same set or it's pulling a new set?
No. So every time the script executes, it pulls a set of numbers, but just when it's setting itself up. For all the rest of the time the script is running, it's using the ones it got at the beginning.
Okay. Gotcha.
Yes, I think that was a nice balance between, starting fresh and not starting fresh. And so how many random numbers do I need? Right? If I'm going to ask random.org, how many do I need? So Monty has to choose where to hide the car. So that's 1 and 3. I then have to choose a first door. That's a 1 and 3. So I'm going to need twice as many between 1 and 3 as there are games in the simulation. So if I want to simulate 5,000 games, I need 10,000 numbers between 1 and 3. Then I have to choose in the random scenario whether to stick or not to stick. That's a binary choice. That's a 1 and 2.
Mm-hmm.
And Monty has to choose the doors, and sometimes he has no choice, but if he has a choice, it's going to be a 1 and 2. So if I fetch twice as many of those, as well as twice as many of the 1 and 3s, then I have everything I need. So I make 2 API calls. Give me 2x times 1 to 3 and 2x times 1 to 2. And then cache those 2.
Okay.
And so if you want to look at the API, it's actually very legible. $num equals 10,000. Give me 10,000, please. Min equals 1, max equals 3, col equals 1, because it gives them back to me as plain text. And so I can either have them like as a grid of 2 by or 3 by, but it's way easier if it's 1 number per line. So a col of 1 just gives you 10,000 lines. That's easier to parse. You say base 10 because if you'd like to have them as octo or hexadecimal or whatever, you could have that. But I was like, no, that's base 10, please. And then the format is plain, so give it to me as text, not an HTML page. And then the last parameter is just say, unless you really know what you're doing, you want rand equals new, so RND equals new, because otherwise we'll give you pseudo-random numbers based on what you tell us you want the pseudo-random numbers to be.
Oh, jeez.
I don't want that. The whole point, right? The whole point is give me good random
numbers. So all
numbers.
of this is a query string in the URL.
Yeah.
And you taught us about query strings.
Text file. Yeah, exactly. Good old, we could write this in JavaScript too, right?
Mm-hmm.
So now we have our excellent random numbers. The next little note I just want to call back to before we run the code is one of the things I adore about PowerShell that made me fall in love with it is that it takes the amazing idea that Bash has of having different output streams. In Bash's case, there's 2 output streams, standard out for normal output and the error output. So std out and std error. PowerShell takes that to the next level and it breaks the streams into 2 categories. Information for humans and data for other scripts or commands.
Oh.
So you have the data stream and you have the informational stream for the humans. And inside the informational stream for humans, you get to divide it into 4. There's debug messages, there are ordinary informational messages, warning messages, and error messages. And so you can really make your script be more or less chatty by basically telling it, show me the debug information. Don't show me the debug information, right? So you have a lot of control here over your outputs. And so I chose to make use of that because, again, it's a teaser. So let's show it the right way. And so the idea is if you have a script that makes a piece of information and you might want to do something with that information in another command, make sure you put just the pure information into the data output. You don't pollute it by making it pretty. It's the data. It's meant to go to another script or command or something. And for the human stuff, well, do make it pretty because that's meant for the human beings. Right, okay. So that's where you want to make sure you use proper English. You can set the color, so I do that. When things go well, I use green, and when things don't go so well, I use red, right? Just cause, right? So that's sort of why the script has different types of output, because that's how PowerShell thinks about the world. Okay, all of that preamble out of the way, let's run the bloody script. So, one last little note. I did this for fun. I didn't want to write tests to see if it works on old versions of PowerShell. So what I always do is I fossilize in place using a requires statement my current version of PowerShell, because I know what works in the version I wrote it in. And then it's effectively, the script is marked as I've only ever been tested in version 7.5 and higher.
Okay.
And so if you're sharing code with other people and they're running PowerShell 4, it's just going to say, no, update your PowerShell and then run Bart script. And so I just always put the requires at the top. So if anyone hasn't updated their PowerShell, you probably want to do a brew upgrade PowerShell, yada, yada, yada. Okay, right. Because I wrote those help comments, we get the equivalent of a man page for free. And so PowerShell's man page equivalent is get-help, because remember, it's always verb noun. So get is the verb, help is the noun. And then you tell it the name of the script. And it will print out all of that lovely documentation like a man page. But the thing we're interested in is the bit at the top of the man page that shows you what arguments are required or not by whether or not they're in square brackets, which for PowerShell will come out as the .syntax section. And I've copied it into the show notes. It's name of script followed by inside square brackets, count, quiet, and silent. They're all in square brackets. This script has no requirements. You can run it with no arguments because all of the arguments are in square brackets. So we can just run it. Okay, then, fine. So ampersand says, please run this script, name of script. Boom. And lots of output goes by.
Wait, what do we do? I'm trying to play along. I've got it here.
Okay, so in your PowerShell terminal, so you have to be in PowerShell.
Mm-hmm.
Ampersand says run something, space, / name of script.
Okay. Okay, cool.
And it'll go woof.
So that works
right
automatically if you open the PowerShell script in VS Code.
VS Code.
And I wrote somewhere what I think you type, is it PWSH in the terminal?
Bing, bing, bing.
Yeah, PWSH.
Yeah.
To invoke it in the terminal. Okay.
Yes.
And bunch of stuff went by and colors and excitement.
Yeah, colors. So what happened there was it played 1,000 games and told you what it was doing 1,000 times. And every time you saw some green, one of the strategies won a car. And every time you saw some red, one of the strategies lost a car. Well, got a goat, I guess. And then you would have seen a bit at the bottom titled results in purple, which showed you the total outcomes from the 1,000 games. And then you'll see the data, because we haven't done anything with the data. The data stream is there. We haven't done anything with it. So it's on the terminal as well. So the human output and the data output are all together on your terminal. And should you want even more, if you do it with minus verbose, it'll tell you like in great detail all of the arguments it's sending off to random.org, and it'll confess all of this little inner detail that I needed while I was debugging this thing.
Okay, I'm not going to do that. I got enough data here.
Exactly. Okay, so if we have this data stream, right? So why don't we do something useful with that? Like, say, convert it to JSON and save it to a file. And then we're not going to see it anymore because we'll be shoving it into a file. So if we pipe our output to convert to -JSON, so the verb is convert to, and then the noun is JSON. That's PowerShell's JSON function.
Oh, okay. That's built into PowerShell?
But yeah, so PowerShell gives you a whole bunch of commands for free, a bit like Bash gives you like CD and grep and stuff without having to think about it. So convert to -JSON is just standard PowerShell. They're called commandlets, but yeah, command. And then we pipe that to out file. So the verb is out and the noun is file. So I'd like to write whatever I just sent it in this pipeline to a file, minus file path results.json minus encoding UTF-8.
So
So
I
we hit
have
that.
I have this on my desktop. So running that, now I've all of a sudden got a results.json file, but I've also got the
Yes.
output I wanted, the final results in my terminal.
Right. So in the terminal, you have still seen the the stuff for the humans came to
Right.
the terminal, but that little bit of data at the bottom didn't come to your terminal. That went to convert to JSON and then to out file.
Oh, cool.
So yeah, so now you only saw the human bit. Now, because I wrote those nice help comments, we can ask PowerShell to tell us what extra options we could give our command.
Mhm.
So if we say get help name of script minus parameter star, now we could ask it for one parameter at a time. If we wanted a description about the count parameter, we could say minus parameter count. But if you just say star, it's going to give you all the parameters. And it'll tell you both what I wrote in English and the metadata because of how I define the parameters. So whether or not it's required, whether it has a default value, right? That's metadata that I didn't have to type in English, but PowerShell knows it because of how I created the parameters. And my English is there. So we can see that count can be an integer. We can see that there's a minus quiet, which is a switch, which is PowerShell's version of a flag. So minus, if specified, suppresses output describing each game. Minus silent is basically get rid of all of the human output. We just want the data stream.
Oh,
that's
so
potentially
quiet is
useful.
just like, shh, you could talk a little, but not a lot. And silent is shut up.
Yeah.
Okay. I looked at that before. I was like, why is there quiet and silent? What's the difference? Okay.
Yes. So let us now so the other thing is, if we don't care about the data, we can make it go away by sending it to out-null.
Oh, okay.
So let's run our script 5,000 times. Let's not give ourselves 5,000 results. So let's use minus quiet to only show us the final totals. We don't want a JSON file or anything, so let's just send the data to null. So then we have minus count 5,000, minus quiet, pipe it all to out-null. And then we just see the important bit. Final results, games played 5,000. When I ran it, I got 1,674 wins by always sticking, which is 33.48%. That is a third.
Mm-hmm.
You know, statistics being what they are, it's never going to be exactly. But that's pretty darn close. Our strategy of always changing door is supposed to be the best. It should give us 2/3, and I get 66.52. That's darn close to 66.6, right?
Mm-hmm.
And our strategy of just choosing again should give us 50-50, and it gives us 50.14. I understood, because I predicted these results, and here are these results.
I love it. I love it.
Oh, you have no idea how happy I was when I ran that script and I saw those numbers.
Yeah. Wow. One of the things I don't think you repeated here, but it's in the show notes, is you had a week of leave, and this is what you did with the first day.
Right.
Because it's fun, right?
Yes. Yes, absolutely. And I could have stopped once I'd figured it out, but this way I got to have content. I thought I'd love to talk to Alison about this, so let's write it up as a teaser script and let's give it a bit of body. So I ended up spending 2 days to get it fully polished and everything, but basically, yeah, it was Monday and Tuesday of my week's leave.
Monday and Tuesday, that's even more fun.
Yeah, and then Wednesday was show notes. Thursday was myself and my darling beloved's anniversary of our civil partnership. Then I did nothing on Friday because we had a really nice bottle of wine. And then today.
What a great vacation. That does sound fantastic.
I think so, yeah.
So I hope that what we're going to do as we go into PowerShell, because this is still the teaser, is maybe we can revisit pieces of this.
Absolutely.
And now
Every piece.
you've got some structure for it, but not all at once, right? You're not going to make us understand it
Oh
all
yeah,
at
no,
once.
no, absolutely. We build it up in pieces, right? You know what? You know how meticulous I am about constructing these things. We've
Right.
been through this with Bash and with JQ, and that is exactly how I plan to tackle PowerShell. Now, I don't know if you want to record this, but the show notes go into a little bit more. It picks out a few little nuggets within the PowerShell. We can do it on air if you like, or we can draw a line under it here. I
I
think we have a
sort of
good
feel
show
like,
either way.
yeah, I think this is good the way it is, because I think maybe you can use these show notes in as you go into the next pieces when you actually start the PowerShell tutorial.
Well, we could definitely revisit this as an example to work around, actually. I think you're right. I think you've just saved me some work when we
Yeah,
do
why not?
PowerShell for real, because explaining this is a really good structure to hang everything on, right?
Right, right, and I think
Scaffolding, that's the word I was looking for.
scaffolding, yeah. Without understanding the structure, doing this, I think, would frustrate me because I don't know enough about it yet to know why I would care. Does that make sense?
Fair. Yeah, it does. Now, the other thing I'll say, right? So when we did our first teaser, we had a bunch of Nacilla castaways who got stuck into PowerShell already.
Mhm.
So there's a portion of our audience who's a little bit ahead of you. So these show notes are already valuable to those Nacilla castaways.
Right.
So you folks can go ahead and have a read. I'm just going to give you the section headings here, and then we leave it at that. Is that
Okay.
a good balance?
Yeah.
So some of the things I want to highlight is how easy so the show notes highlight this, how easy PowerShell makes it to call that web API. We're reaching out to random.org with the URL. How's PowerShell at that? It's great, right? It's a one-liner, invoke web request, right? Verb, noun, invoke web request. The other thing is that, do you remember in JQ, it took a while to get our head around how it deals with filtering a list, because we would think in terms of looping, right? When you're writing JavaScript, you're looping over. Arrays are for looping, right? That's how we think about the world in JavaScript. But in JQ, it's always about filtering. So you take a list, you apply a condition, and you get a shorter list. PowerShell thinks about things like JQ. So when we want to choose which door Monty picks from, we filter it by saying Monty is not allowed the one with the car or the one I've already guessed.
Oh, okay.
Right? So we use the where object, which is our filter. So we give it a list of all the possible doors and we filter them, and then we're left with a new array, which is why I was able to see array of 1, array of 1, array of 2, array of 1, array of 1. Because I was using this filtering approach.
And things
So I
were
was ending up with
disappearing.
different size
Right?
outputs. Yeah.
Huh.
Oh, and actually, that's all I have. There we go. That was easy. Right. Yeah. I think the final thoughts we've kind of hit on, right? So because it's fun and the act of writing the code forces you to think in a way that English doesn't, it forces you to think more deeply. So if you want to truly understand the problem, teach it. Teach it to Alice. It actually is really effective because you get away with nothing. No hand waving allowed here. But writing it in code forces you to be precise. And any detail that's fuzzy, well, it can't be anymore. You're going to have to get it real. And then you can run it and test your assumptions.
I really like the way you're saying that because I've got something I'm noodling on automating, and I can tell that as I'm trying to draw just little cute flow diagrams that I'm going to not get to what I need to get to because I'm going to forget conditions that, like, oh, what about when that happens? What about when that happens, that you'd have to when you actually code it?
Right. Yeah, constraints. Code is a great way to get constraints out because otherwise they're called bugs.
That's got to be the way to end the show right there, Bart. That's perfect.
Right. Okay, folks. Until next time, happy computing.
If you learn as much from Bart each week as I do, I'd like you to go over to lets-talk.ie and press one of the buttons over there to help support him. He does 98% of the work here. I'm just the stooge that listens to him and asks the dumb questions. If you go over to lets-talk.ie, you can support him on Patreon, you can donate via PayPal, or you can use one of his referral links. I really hope you'll go over and help him out. In the meantime, you can contact me at Podfeet or check out all of the shows we do over there over at podfeet.com. Thanks for listening and stay subscribed.